I think both Stefano and Amin's talk gave us a quite good example of how the understanding of element can contribute to the interpretation and design of the field testing. So I think now any question from the audience?
Yeah, sure. I have a question for both. Very nice presentations, excellent, both of you. Very interesting. Why does it always fail the slope? Why does it fail at night?
Thank you, Yannis. That's a very nice question. We actually aim to fail around 8 in the morning, but actually was earlier, but we were lucky enough that there were people there to take picture and video. So we need to do better for the next time.
I think it has something to do with the moon. I have
no, it is a funny question, of course, obviously, and everybody's laughing. I was laughing myself when I was thinking about it. But does it have to do perhaps anything with vegetation, the trees? I don't know. Or the statistical, let's say, data of 2 out of 2 is not enough?
I think the second.
The second.
Yes.
Okay, thank you.
Any other question?
Okay, so my question relates to these gassy soils, which Stefano presented. So when we introduce gas into these soils, is this gas dissolved in the pore fluid, or is it introduced into the air voids?
Yeah, thank you for the question. We actually flush the sample with water. Inside the water was dissolved CO2, and then we reduce the cell water pressure in undrained condition in order to exsolve basically the gas. Because for us was also quite important to actually assess if the exsolution process could have caused some softening on the soil fabrics. So we are not flushing gas directly, but we are flushing dissolved gas and then exsolving gas by reducing the confining cell pressure in undrained condition.
The tests were in saturated condition.
Sorry?
The tests were in saturated condition or unsaturated?
When we performed the flushing, the sample was fully saturated. After the gas generation, we basically test unsaturated conditions or gassy conditions. So the degree of saturation when we performed the final steering stage was ranging between 87 to 92%, depending on the amount of gas that we were able to generate.
Any other questions?
Thanks for the presentation, and your project is wonderful. What would be your advice to the practitioners, how they should react when they get the results of laboratory testing of peat with the 55 degrees friction angle, for example? So should we use it or somehow discuss it with the laboratory?
Yes, that's a very tricky question. Let's say there are 2 points of view. The current approach in the Netherlands could be considered also over-conservative, because if I look at the, let's say, the Eurocode transfer in the Netherlands, the friction angle for peat is given by 15 degrees, which I understand is conservative, but it seems really over-conservative. Now, for what concern which kind of friction angle we want to use in the practice, that's a matter of discussion. It depends on which type of, let's say, problem you're facing. If it is a problem where you are looking at the ultimate state or serviceability limit state. So in my opinion, I'm not able to give you really a number because it depends from several factors, but definitely 15 degrees of friction angle seems over-conservative. At the same time, 60 or 70 degrees of friction angle are not realistic. The question is how much, in my opinion, can we trust on the fiber's contribution in the field? So how much are we able to engage the fibers in a field application? Because obviously the fibers give you quite a side effects, which is basically size effects. So the fibers, which is 5 centimeters long, might count a lot in a sample which is 10 centimeters in diameter. But what about the size effects of the same fibers in the field when you're actually looking at a problem which has scale completely different from the laboratory? So the best way to tackle this problem to me is including in a constitutive model the role of fibers. and trying to assess by back analyzing laboratory data how we can include or not the fibers.
Thank you.
I might answer posing
What?
more question than answer, but it's an open issue at the moment.
One more question for Amin.
Yes.
You showed that there is a clear difference when you have vegetation and when you don't have vegetation. I'm talking about your centrifuge experiment. Is it the 4 kilopascal cohesion only, or is it also the fact that the vegetation perhaps is sucking water? Like,
Yeah, indeed. In long term, vegetation has two effects. One of them is mechanical reinforcement. The other one is changing the hydraulic regime around the roots. In my case, because the rain duration was scaled by a factor of 1/n2. So this sucking of the water was not really did not play a role. But indeed, in reality, it does. Yeah. And also for my centrifuge test, because I wanted to have a comparable surface with the unvegetated soil, I cut the leaves. So when you cut the leaves, basically you also, I believe, eliminate the tendency for suction from the roots as well. Yeah.
Okay, any more questions?
What scaling effect for the roots? You also test not in the centrifuge with the same roots, so but I think you wanted to model the tree roots or original model.
I guess this question is very similar to simulation of peat, because you basically, by simulating a rooted centrifuge element, you are adding some natural fibers to the sample, and by basically this you cannot. So the scaling effect for the root diameter is not n. In normal centrifuge scaling factor, we say that the geometry, linear geometry, is multiplied by n to get the prototype. But in this case, I believe it's not correct, because you are basically testing a global bulk behavior of a material that has some fibers inside. Therefore, you cannot say that this was actually this oat, this Avena sativa, had a mean diameter after, I think, 28 days of about 1 millimeter, and I performed the test at 50 G, so I cannot say that this root was I don't know, a 50 millimeter root in the reality in Rödlingen.
So it belongs to the material.
Yeah.
That's all for this morning. So I think I will just close this session, and thank you, Armin and Stefano, for the nice presentation. And we will